Hello students, welcome to Sourav Sir Classes. Our website is www.souravsirclasses.com. Also, you can call us or WhatsApp us in this number. And this lecture is about chemistry, and we'll be doing some physical chemistry part of theory of gases will be our topic. So let's start with the first topic of this lecture, that is gaseous law. So here in the gaseous law, our first law will be Boyle's law. So first let me tell you, there are so many laws on the basis of gaseous law, and the first one is Boyle's law. B-O-Y-L-E ' law. So first one is Boyle's law. So second law that we have to study is our Charles law. Charles law. This is the second one. The third one, that is C, is Dalton's law of partial pressure. So it's Dalton's law. Then after this, another one is the van der Waals equation that we have to study, but that is not in this law portion. Okay, so the last one is Graham's law. So option D, that is Graham's law. And Graham's law is a law of diffusion, and this is a law of partial pressure. Okay, so let's start with the Boyle's law. What is Boyle's law? Okay, so let me write first one, that is Boyle's law. So here in Boyle's law, the law is about the relation between the volume of a gas and the pressure of a gas. So here the relation of a volume of a gas and the pressure of a gas is inversely proportionate, means V will be inversely proportional to the pressure of a gas, and we denoted V as volume of a gas and P as pressure of a gas. But this condition is only satisfied when the temperature is constant. And also there is another condition, that is it has to be a definite mass. So definite mass of a volume of a gas, obviously. So here the condition is T and M should be at constant volume or constant condition. So here then the Boyle's law will be defined as at constant temperature, for a definite mass, of a gas, the volume is inversely proportionate to the pressure of a gas. So this is the Boyle's law. So already I have given the mathematical expression, that is V is proportionate to the 1 by P, that is V is inversely proportionate to the P. Okay, so here this will be another time I'm writing it as this, when T and M is constant. This is the condition of a Boyle's law. Now let's move to the another part of gaseous state or gaseous law, that is the graphical representation of Boyle's law. So for the first condition, that is the graphical representation of Boyle's law. So when P versus V means pressure versus volume, then if this is the condition, then the mathematical form of Boyle's law will be V varies as 1 by P, or we can say V is equals to K by P. Okay, by putting constant, K is the constant, constant. So in the next step we also can write PV, this PV equals to K. So then if PV equals to K is the condition, then what will be the graphical representation of the Boyle's law? So here the graph is like this. This is our x-axis and that is for volume, and for y-axis we are taking P. So here if PV equals to constant, then our graph will be like this. Okay, so this is the graph will look. Then it was the graphical representation of P versus V, that is the pressure versus volume. And the next condition is when V versus 1 by P, or we can say P versus 1 by V. Same, this is as V is inversely proportionate to the P. So in this case the mathematical form will be V varies as 1 by P. Again, like the original one, we will start with the original one, and then in the next step we can write V equals to K by P, right? Also V varies as 1 by P, or we can write P varies as 1 by V. And from here we can write P equals to KV, right? So here the graph will be look like this. For first condition, that is V varies as 1 by P, graph will look like this is the x-axis and the y-axis, right? And if we take 1 by P here in the x-axis, then V in the y-axis, then it will be a straight line passing through the origin with the slope K in each case, that is for V varies as 1 by P, and also in the next case that will be with satisfy P varies as 1 by V. So in this case also it will look same. This is the graph, and this is pressure, and this is volume, and it will make a straight line passing through the origin with slope K. So this is the P versus 1 by V or V versus 1 by P graphical representation. Now let's move to the next representation in graph, or that will condition of the representation of many terms of Boyle's law. Let's see the next one. So next is log P versus log V. The mathematical form of Boyle's law is V varies as 1 by P or P varies as 1 by V, or we can say P equals to K by V. K is a constant. So taking log on both sides, so it will be log P equals to log K, and this divide thing will be minus in case of log. So log K minus log V. Hence the plot of log P versus log V will be like this. This is the graph. In the x-axis I am taking volume log V, and in the y-axis it's log P. So it will give a straight line with slope, that is slope will be equals to -1, and intercept will be equals to log K. So it will be this. So this is the log P versus log V. Now the next one, that is PV versus P or PV versus V. So for this, the mathematical expression will be starting with V varies as 1 by P. That is the main law of Boyle's law. That is the mathematical expression of Boyle's law. So in the next step, we can write P varies as 1 by V as well. And here we will be taking K as constant. So we can use equal sign. So it will be P equals to KV. So from here we can write PV equals to K, right? So this will be a divide sign. Okay, so it will be then PV equals to K. So when we are considering PV versus P, then it will be a straight line. So the graph will be, if this is pressure here in the x-axis and in the y-axis PV, then the graph will give a straight line that is parallel to the p-axis and with intercept K. And similarly, when we are representing PV versus V, then again I am drawing the graph, and here V will be in the x-axis and PV will be in the y-axis. Then also it will give a straight line parallel to the v-axis and intercept K. So this will be the graphical representation of the Boyle's law. So these were 4 graphical representation of Boyle's law. So basically we are done with Boyle's law. So in the next video we will be doing some more gaseous law. So thank you for watching this video. If you like the video, press the thumbs up button. If you have any inquiry, you can comment us in the below section. Thank you for watching.